Hi, my name is Troy, and this is the gummy bear experiment presentation. So for this experiment, early this morning, I put a gummy bear into a water and salt solution and let it sit in there for about 7 hours. And then I took another gummy bear and put it in another solution that just consists of normal tap water. And let that sit for the same amount of time, like 7 hours. And then this is just the original size gummy bear, just for size comparisons. Before explaining what happened in this experiment, I just want to go over what I thought would happen is I've done this experiment before. You probably have, maybe in grade school as well, with I think boiled eggs or just regular eggs. You put it in like a vinegar and solution, or vinegar and water, or just regular water solution, or salt. I believe this is kind of, from what I remember, working with the same concept of osmosis. And just a brief little definition of what osmosis is. It's just the passage of solvent molecules or particles, the movement of those particles through membrane, usually being selectively permeable, which means it only allows certain size and types of particles to move across that membrane. One way or the other, kind of like a gatekeeper, so to speak, when past that gate. And for osmosis, again, it's the movement of the solvent particles from a more dilute solution to a more concentrated one. And so in this gummy bear experiment, that semi-permeable membrane would be the gummy bear itself. So in osmosis, there are three different types or of solutions that could occur. You have an isotonic solution, which is when the two solutions have the same osmotic pressure, which means there's really no passage from it's pretty much, the solution is in equilibrium, so there's no little to no movement there in the solution of. Then you have a hypotonic solution, which is where the solution has a lower concentration of a dissolved substance. Then you have the third one, which is a hypertonic solution, which means it's a solution that just has a higher concentration of dissolved substances. And so again, just for reference, this is the original size. I try to pick the same color of gummy bear. So just for size comparison there, it's kind of like just a little, almost the same size as the first little part of my thumb there. Actually a little smaller, sorry. So there's that. First, we have, this here is just 100 milligrams. You can tell by the markings there, about 100 milligrams of a salt water solution. There is still some salt granules here, so this is a saturated solution. This first little gummy bear, I'm just gonna take that out. Oh, wow. First little gummy bear is, compared to the original size gummy bear, is slightly smaller, if you can tell, from being sitting in that solution for about 7 hours. So I predicted that the gummy bear in the salt solution would shrink, would be a little smaller, and that was the case. So that would be a hypertonic solution, the gummy bear in the salt water. There was a higher concentration of dissolved solvents outside the gummy bear, so that is where the water from inside the gummy bear traveled through the gummy bear, or kind of left the gummy bear being the selectively permeable membrane, to the outer solution, causing that to shrink original gummy bears shrink. In this cup, he have here is another 100 milliliters, or 100 mLs of just normal tap water, and put the gummy bear inside there, and take that out, and we'll do another size comparison. Oh wow! When kind of like the egg experiment, explaining the same concept, I did predict that the gummy bear would be bigger. Sorry, it's a little slippery in my hands, but oh, it's kind of falling apart. But this is the original size gummy bear. I'll kind of put that away so I can hold this. And this is the gummy bear that's in the tap water. It's kind of hard to see if I come a little closer, but it's significantly larger than the original gummy bear and the gummy bear that was in the Hypotonic Solution. So the gummy bear in the normal tap water demonstrates a hypotonic solution where the gummy bear grew, which means there is a higher, excuse me, there was a lower concentration of dissolved substances outside the gummy bear. So the water from the tap water solution entered into the gummy bear, which had a higher amount of dissolved substances, and just caused that gummy bear to grow larger. I guess to kind of bring this to like a real life application, I think this is why they say you should not drink salt water. You hear the stories of people trapped at sea, with all that water, but it's not drinkable, because if you did ingest and drink that salt water, again, your gummy bears, I'm kind of related this to your cells of your body. Just the concentration of the dissolved solutes end up resulting in being the gummy bear in the salt solution. So drinking the salt water causes the water from the inside of your cells to leave to go to a higher concentration of dissolved substances, being that ocean salt water, causing your cells to shrink, and then obviously that could create problems. And I believe drinking enough ocean or any salt water results in death. So that's kind of like a real life application I kind of relate that to, and learning about osmosis and this little mini experiment.